Okay, let's continue with inheritance. Let's just review what we have done last time. Basically, we have to worry about how you can use the super and extend keywords for code reuse. We'll start with that, and then we'll continue with lots of interesting stuff building from there. Okay, let's just review, making sure everybody's on the same page. First of all, this is how you can implement inheritance, and this is everything you need for lab number 5. That's all you need, but we'll definitely go way beyond lab number 5 today. Okay, let's review. Basically, what you have to know is, for inheritance, you use a keyword called extends. So that's how you reuse code from your parent class. And in this case, we have basically a superclass called students. And then we define the common attributes that's going to be shared or inherited to the both subclasses. So we got name, registered courses, and number of courses. So these are the 3 attributes that will be available at both resident students and also non-resident students, right? As we said. And also we got constructor over here, and this method here will be inherited verbatim to the both subclasses. And this get tuition will also be inherited, but it will also be redefined or overridden, like how you override the equals method in both subclasses. And over here you can see that for the resident students, for example, we say that it extends the student class, but we don't have to repeat these 3 attributes because they are simply inherited. And also we don't have to repeat the register method, it just inherited verbatim. But we do redeclare the method for get tuition over here. What we did was we used a super keyword here to make use of this particular fragment of code by using super. And then we do something that's more specific to this particular subclass using the premium rates. Okay, and symmetrically, we do the same thing for the non-resident students class where we do have discount rate. Okay, that's about the code. Now, let's summarize what we have done very quickly. This is what you can do for every subclass. Basically, you inherit all the attributes and methods from your parent class. Let's not worry about private. Let's assume that everything is not private. Okay, you inherit everything, every attribute, and every method from your parent class. And now let's talk about visualization very quickly. Let's say over here we declare 3 variables. We got S, we got RS, we got NRS. Okay. Now I want to introduce one term to you right away. Whenever we declare a type for the reference variable, which we simply say it was a type before we talk about inheritance. But now we want to be more specific because there will be 2 kinds of types as we'll see today. Whenever you declare S, RS, or NRS, to the left-hand side of the variable name, this is something called static type. Static type in the sense that it doesn't change. Once you declare the variable to be of a particular type, it doesn't change. Now, what can a static type do for you? We'll see in the next page. Okay? So now, how do we visualize every objects? For example, in the case of the variable S, we know the static type is simply students. So the way we visualize a student's object at the runtime is to look at what attributes you have declared in that particular class. In this case, we got name, we got registered students, registered courses, also got number of courses, right? That's why we got 1, 2, and 3 attributes over here. Okay. Now let's get to one of the descendant objects. One of the child objects. For example, what about RS? RS, the static type is resident students. And now how do we visualize a resident students object at runtime? Okay, RS over here, we know that resident students is over here. What attributes do we have for this particular class? So you have to consider all the parent classes, or at least in this case, simple case, we have to consider both student and resident students. Not only that, you got the attribute called premium rates, but also you get all the attributes from your parent class, right? That's why at the runtime, for the resident students, you got name, number of courses, registered courses, and premium rates. So you got 1 more attributes for this particular objects of type resident students. Okay, so far so good? Okay. And similarly, what about non-resident students? In this case, it will be just some extra attribute called discount rate. Okay, let's go a little bit even further. Okay, that's basically what we left off from last time. Why is static type so important? And we'll see everything built on top of how we understand about a static type. Let's say again, very important. Over here, I want you to pay attention to just this attribute again, just S over here. We know that students over here is the static type of S. Static type tells us about the expectations. So what's really expectation? Expectation simply means what method or attributes can you call on this particular variable given its static type. For S over here, as we talked about last time, if you see from this particular hierarchy over here, what attributes and methods are defined on the student class? Well, we got name, registered courses, number of courses, we got also register, also we got get tuition. So these are all the expectations for any static type students. Okay? Now, that's why you can see that these can all be called by S. Okay, you can say S.name, S.rcs, S.noc, S.register, S.get tuition, right? Okay. However, you cannot say S.get premium rates. You cannot, because premium rates simply was not declared over here in this class. Okay. Now, one thing that's really important, I want you to pay attention to this. Have a look at the resident student class. You can see that this is a child class versus this is a parent class. As far as you can see, can we expect more from this particular child class? Can we expect less or more? More? What's the additional expectation you have for this particular class? Huh? The premium rates, right? Exactly. Because not only that we inherit all the attributes, all the methods from the parent class, in addition, we got one extra expectation, right? That means we got, for example, the premium rates and set premium rates. So these are the two new expectations in the child class. So what does that mean? That means in general, if you have any arbitrary inheritance relationship, when you go in this direction over here, go from the parents to the subclass, you're basically increasing the expectation. Because we are always inheriting at least as many methods and attributes from your parent class. In addition, we add some additional attributes or methods. That's why we get more and more expectation. Okay, that's basically review, just from last time. Any questions before? Yeah.
So, can reference are all reference types static types or primitive types?
When we talk, good question. So when we talk about static type, we only talk about reference types. Okay, yeah. Especially we talk about static type in the context of inheritance. Yeah, before we also talk about reference type, in the up to now. But since there was no inheritance, we don't have to say they are static or dynamic. But now we have to, since we talk about inheritance.
Maybe I dismissed because I was a little late. I get expectations. What do you mean when the reference is static? What do you mean by that?
Okay. As far as now is concerned, you only have to know when I declare this particular variable S, okay, the type is simply just students, right?
Yeah.
That's its static type. That's what I meant. Okay, static type. Okay.
But what if we say student S equals to new resident student?
Let's not worry about it. We'll get there. So now we only talk about declaration. All right. Now let's do some exercise together. All right. I want you to consider this fragment of code over here. All right. And then I will draw a diagram for you in just a moment. But I want you to get some intuition. Okay. This is one of the most important topics, one of the two most important topics for inheritance. Okay, let me just get it. It's called polymorphism. Okay, but don't worry about the name. Let's have a look at line number 1. What we have is, we have a students as objects, just creating that. Line number 2, we have a resident students are as objects. So now we know what their static types are, respectively. And then we also set the premium rates for this particular resident student to be 1.25. Okay? Now, I want you to consider line number 4 and line number 5. Do they both compile? Or they both don't compile? Or one of them compiles? Think about it. Have you learned about inheritance before? You just have some intuitive idea. Yeah?
If that one worked, wouldn't you have passed?
Nope, nothing about it. I'm just saying whatever you have over here is the question. I'm just asking for line number 4 and line number 5. Should they both compile? Should they both not compile, or at least exactly one compiles? Okay, if you say one of them is going to compile, which one? Number 5 will compile. Anybody agree? Number 5 will compile? Well, we can take some consensus for now. That's okay. But knowledge is not up to consensus. But we'll just see what your attention, what your intuition is. 5, you say 5 will compile, but 4 will not compile, right? Huh? Okay. Okay, that's quite. Maybe some of you think that's 4. Maybe seems to be more people thinking about it's 5, right? Before I try to tell you the reasoning, let's double check with Eclipse so you can also try that. Let's go to Eclipse over here. That's the example I gave to you on the web. Basically, I recreated the S and RS, right? So the static type for S is students. Resident student is the static type for RS. Let's try the first one, number 4. Number 4 is S is RS. S, RS. No red underline. That one compiles. What about the other one? No. That one does not compile. However, if you move your mouse over, let's see what the error message is. Sometimes it can be useful, sometimes it can be useless. What does it say? Type mismatch cannot convert from students to resident students. Does it make sense to you? It doesn't make sense to me, to be honest, if I were to learn about the idea. No. Okay, that's what you can try. Now, by the end of the lecture, what I expect from you in the exam and in the test, when you are given lines like this, you should be able to tell whether they should compile or not. That's what we're going to learn. Okay, let's go back to that particular example. At least we know from the tool, from Eclipse, this is okay, this is not okay. It all boils down into expectation. All about expectation. Okay? Let's be 100% logical over here. 100%. Okay? Now, what I want to do is, let me draw a diagram very quickly for you. Can we just see exactly what's going to be the runtime structure that's going to look like from 1, 2, and 3, first of all. Okay? Let's do that very quickly. For line number 1, S is pointing to a student's objects. Of course, it has the attributes name, number of courses, and registered courses. Right? I'll just put the attribute name. The value doesn't really matter in this case. Okay? That's about the student objects. And the second line over here, how does RS look like? Would it look like the same as S? Or maybe bigger? Bigger, premium rates, right? RS is now something like this. Okay, we got, I'll say RS for resident students. Not only that, we got all the attributes from students, but also, I'm going to put in a different color. We also got the premium rates. In this case, 1.25. Okay, now, what we have is line number 5 is not going to compile. What does that mean? What does that mean? You all learn about something called proof by contradiction, right? How does it work? Let's assume something we would like to prove. And then from that thing over there, we'll get down to something that's completely false. That means our initial assumption was false. So that means the opposite should be true, right? That's proof by contradiction. So the way I'm going to evaluate this is, I'm going to assume, what if this line is going to compile? Which means that line can be executed at a runtime. And then I will show you how badly things can go into. That means our initial assumption that it should compile is simply false. So it should compile. Make sense to you? Completely logical. Let's try. If I allowed this particular line to compile and then execute this line at a runtime, how am I going to change the pointer? Well, am I going to change the pointer of this one or this one? The right-hand side or the left-hand side? Right-hand side, right? I'm changing RS to point to wherever S is pointing to. That means RS is not going to point to here anymore. It's now going to point to a student objects. Okay, first of all, step number 1. And then let me write it down. Let's assume RS is assigned to S, compile. So it can be executed. Now, at the runtime, how do we know what methods can be called on RS? How do we know? So now, continue from here. What can we call on RS? It's about the expectation, right? What's the expectation on RS? Well, how do you infer the expectation for RS? You have to go to its static type, right? RS was declared over here with the static type resident students. That means everything that's defined in the resident students and also whatever that's inherited from its parent class should be able to call on that particular class, right? Including premium rates, set premium rates, name, registered courses, and number of courses, right? So that means over here, I'm just going to put it here, okay? So we got rs.name, rs.registered courses, rs.number of courses, and also rs.premium rates, rs.set premium rates. So these are all the expectations. But do you see any problem of executing these expectations at the runtime? It seems like, okay, good. So when we say rs.name, which attribute are we getting? The name. When we say rs.name, we're getting this attribute, no problem. When we're executing rs.registered courses, this attribute. rs.number of courses, this attribute. What about we do rs.premium rates? There's no premium rate for student objects, is it? So that means when we try to execute this particular expectation, it's going to crash. There's simply no such stuff. You're referring to something that doesn't exist. It's going to crash. So if we allowed this line over here to compile, the consequence is we might crash at the runtime. That means this shouldn't compile in the first place. Okay, so that implies RS is assigned to S should not compile. Okay, guys, that's the first one. Any questions about this? No, it's nothing, you know, I tell you what, we'll get a little bit deeper into it. I'm just trying to give you some intuition, right? Basically, we're trying to see S is assigned to RS versus RS is assigned to S. They seem to be doing something very similar, but I'm telling you, they're doing something fundamentally different, okay? Now, let's apply the same logic over here. Why would line number 4 compile? Why would it? Okay, why would it compile? If we say over here, S is assigned to RS. So what does that mean when we say that? That means S, rather than pointing to over here, S is now going to point to this particular resident student's object, right? So now, what can be the expectation on S? Well, the expectation on S could be, I can say S.name, S.registered courses, and S.number of courses, right? S.name, S.registered courses, S.number of courses. Can I say S.premium rates? In fact, you cannot, because that's not part of the expectation. You can only use a dot notation if it's part of the expectation for the static type. If it is not there, you simply cannot call. All right? Guys, are we okay, or you need repetition for this? Guys, are you okay? Are you okay with that? Hello. Are you all right for that? A little bit? Okay, maybe we'll get to a little bit more. Let me take questions first, and then we'll see what to give. Yes, go ahead.
Okay, so as long as we know that line 4 is going to compile, what will it happen when we what will happen to the premium rate?
That simply means premium rate. Oh, okay, the question was for line number 4.
Yeah, we know it compiles.
Yeah, for line number 4 over here, it will compile. But remember, we can never call S.premium rates, right? Because premium rate is not part of the expectation for the static type for S. That means even though you're pointing to a resident student object, but it's not going to be used. That simply means that. Okay? Okay, any question about this? That's the first challenge for you to really get through. Okay? Let's now go to the second one. Guys, seriously, do you want any repetition for the whole reasoning? If you need it, just raise your hand. Okay? Why don't we do it again? Why don't we do it again? Let's start from scratch. Okay? Now let's do it again. Let's see, this is what we want. We know that this line over here is not going to compile from Eclipse. However, this line number 4, is going to compile. Okay? Now, this is how we're going to judge. This, first of all, you should know about the expectation. Expectations over here, if you only look at S and RS, what would be the expectation for each one of them? The expectation for S versus the expectation for RS. How do you figure out the expectation? Look at the static type. Students versus resident students, right? What would be the expectation for students? Name, registered courses, number of courses, right? These are the 3. So that means you can always say S.name, S.registered courses, and also S.number of courses. If you try either of the 3, it will simply compile, no problem. If you try S.premium rates or S.discount rate, no, they will not compile. Okay, let's start with that. Okay, what about the expectation for RS? Well, RS.name, you can say RS.registered courses, RS.number of courses. Now, can you say RS.premium rates? Of course you can, because RS, the type is resident students, and resident students over here does have premium rates. Right? Just look it up, right? Can you say RS.discount rate? Can you say that? Well, all you got to judge is discount rate defined in this resident students class? No, right? Discount rate is over here. Okay, so that's no. Okay, given this, let's try again. Okay, that's the background from last time. Now we want to see why this particular line would not compile. Again, let's assume it's going to compile. By assuming that this is going to compile, that means we are allowed the reassignment to occur. And if the reassignment is going to occur, RS is going to point to some students' objects. Right? Let's try that, first of all. What I will do is I'll say assume RS is assigned to S compiled. So now, what happened at the runtime? If they compile at the runtime, this is what's going to happen. So S over here is pointing to a student's objects over here. And we know that for the student objects, we got 3 attributes: name, registered courses, number of courses. Name, registered courses, number of courses. So these are the only 3 attributes for each student objects. Versus, we have RS is pointing to a resident students objects, or just say RS over here. And we know that not only that we got all the attributes from the student class, we got name, we got number of courses, and also we got registered courses, right? So registered courses, a number of courses, and we got more. Because at the resident students class level, we also declare new attributes called premium rates. So put the premium rates over here. Okay, that's what we have at the runtime. Okay? Now, if this reassignment over here was allowed, so what does that mean? That means we allow RS to point to wherever S is pointing to. That means RS is pointing to this particular objects, and that object there at the runtime does not have a premium rates. However, if you look at RS over here, what was its expectation? Over here. One of it is RS.premium rates, which is completely compilable. It will compile, but what if we try to say RS.premium rates? RS.premium rates will simply just crash because there's no such attribute at the runtime. It will just crash. So that means our initial assumption about this line should compile was wrong. It should not compile. Okay? So this will just crash. So now that means this should not compile. Okay, better for you? All right. Guys, are we right? Any questions? If you have a question, better ask me now. Okay? Yeah.
Got the logic. It was just when you first read line 5, you almost read it as RS is assigned to S, which seems fine.
Right?
But it's just, you have to think about where it pointed to.
Exactly. So that's why I'm trying to explain to you the logic, right? I don't want you to memorize the rule. We do have some rule for you to follow, but you really want to know exactly what's happening there. All right? Let's now go to the next example. That's about polymorphism, which means you can.
Also, like, for example, let's say you just write out premium rates for your resident students, just for example. Would RS equal S just compile in that case?
Say it again. I want to get, yeah.
Premium rates.
I see what you mean. So the question was, hypothetically, if we simply remove the declaration for the premium rates from here, right? And then, so now that means we got exactly the same number of attributes between resident students and students. In this case, it seems like this kind of crashing scenario wouldn't occur anymore. Would it still be allowed to compile? The answer is no. Because potentially, later on, you can still add new attributes to here, which you can always do.
So it wouldn't compile even if you strike out?
No, it doesn't matter. As long as, we'll actually see the rule very quickly, but I just want to use this scenario here to show you why it wouldn't compile. But in principle, you will always get some new attributes and new methods in your subclass. It will be very rare if you don't have any new attributes or methods in your subclass. All right? Yeah. Yeah.
So based on line number 4, then can you say student RS equals new resident ratio?
You're saying based on line number 4?
Yeah.
So,
Can you write student RS equals new resident?
you do, oh, sorry, I don't quite get it. You want to change line number 4 or what?
Based on number 4,
Yes, correct. Based on line number 4, that means students now, S is now going to point to exactly this object over here, Rachel. That's correct, if you draw the diagram.
but so in line number 2, can you then write student RS equals new resident student?
In line number what?
2, you write student RS equals to new resident student.
So you want to say students over here,
Yeah.
RS is assigned to new resident. You know what, we'll get there.
Oh, okay.
Yes. The question was, can we simply put different types on both ends? The answer is, yes, you can, but it's subject to certain rules. Okay, we'll get there. Okay, now second one. This kind of builds on top of the previous one. So this one is something called dynamic binding. We're going to see some runtime behavior. Okay, so what we have is, we have a course objects. EECS2030, and then over here we have basically student S. We know that S, the static type is simply students. So this is a static type. So that means we can call S.name, S.register courses, S.number of courses, S.get tuition, everything that's defined at this level over here. Okay. Now we got line number 3 and line number 4. We are creating basically 2 new objects. One is of type resident students, the other one non-resident students, okay? We'll get a little bit later to see why these 2 types can be different. We'll get there, okay? But let's not complicate the matter, okay? Based on what we have got so far, we got RS pointing to a resident students objects. And that one for sure got a premium rates. And also that one is Rachel. Okay, that's from this line. What about line number 4? We got NRS pointing to a non-resident students objects who is Nancy over here. And we got all the attributes from students. In addition, we also got discount rates. Okay, and over here you can see that we set the premium rate to be 1.25. I'll put it here. And eventually we'll set the discount rate to be 0.75. Okay, that's what we have. And I'm just going to omit in the diagram, we're also going to register EECS2030 for both students. I'm going to omit that part, okay? But we'll get that. That, let's say, is only $100 for that course. Now, let's focus on these 2 lines, 7 and 8. Okay? Now, based on what we discussed before, right? We know that this is going to be okay. S is assigned to RS, right? That means we can do S is assigned to RS. And then we're going to basically see what's the return value for S.getTuition. Okay, and then we're going to do another reassignment to say S is reassigned to NRS. After that, we're going to say S.getTuition. Okay? Without drawing anything on the diagram yet, can you predict what the output might be? What should be the output from S.getTuition over here? And what should be the output for S.getTuition over here? Let's start with something simple. These two lines are exactly the same, S.getTuition. So at the runtime, should they give you the same value though? Okay, so if you don't think that should be, so what should they, how would they differ? Okay? The key really is when you got this line over here versus this line over here. That's really the key. Okay? When you are trying to do reassignments at the runtime, especially when you got inheritance, you're changing the types around dynamically. That's why it's called dynamic binding. Depending on which dynamic type you're pointing to at the moment, it depends on, it's going to affect which version, in this example, which version of the getTuition is going to be called. Let's see. Let's start with this. Let's say this one here, S is assigned to RS. So what does that mean? That means, let me just declare S first, right? We have S over here. I'll put S over here, okay? So now, when I say S is assigned to RS, what it will do is, it's going to say S is now going to point to wherever RS is pointing to. And now, when I try to call this method over here, S.getTuition, which version of the getTuition is going to be called? Well, we got three versions of the getTuition. We got three. Version number one, the base amount in the student class. Version number two, the redefined version in the resident students class using the premium rates. The third version, the redefined version in the non-resident students class using the discount rate. We got three versions. So now the question is, when we call this particular line, which version of the getTuition are we calling? The premium rates? How do you see? Well, somehow you can see, if you can draw the diagram, S is currently pointing to the objects of type RS, which has the premium rates. And Java runtime is going to make sure, because this is the most specific type you're pointing to, it's going to call whatever most specific version is for the method for you. So now, when you say S.getTuition is going to be the version over here. Okay? So now, in that case, it's going to apply 100 to the premium rates, which is 1.25. So you get 1.25. Okay? That is why you see That's why you will see 1.25 over here. But by applying 1.25. Now, apply the same logic. If I try to do the next line, the green one, if I say S is assigned to NRS, so what does that mean? That means S now, rather than pointing to over here, is going to point to wherever NRS is pointing to. So now we are changing the object we are pointing to. Okay? Now, if I say S.getTuition again, which version is it going to call? Is it going to be the version over here? Over here? Seems to be the idea, right? Because S is pointing to this object over here of type NRS. And that one does have the discount rate, which means we're going to apply the discount rate to the course. That's going to be 75. Okay? Okay, any question about this? So the two slides, we got two different ideas, but they built on top of each other. Let me recap, and then you can ask me questions. The previous one, over here, we are basically talking about you can only do the assignments like this, like a S is assigned to RS. We'll talk about more about the rationale, like a rule that you should follow. This is the only one you can have as opposed to RS is assigned to S. Okay? Building on top, we say that, so here we only talk about compilation. whether one line should compile or not. The next one, we talk about given that things are going to compile, what's going to happen at the runtime. And the first one is saying that we are going to reassign S to RS, which means it's going to point to this particular objects. And when we call get tuition, it's going to call this particular version in the resident students. And then after reassigning S to NRS, which means it's now going to point to NRS objects. Now the dynamic type, which we'll talk about, is now non-resident students. Now it's going to apply the discount rate for the get tuition. So it's going to give us a different value. Okay? Yeah?
Can I just use the proper context doctrine? Like, why are we doing this?
We'll see very soon. We'll see eventually. Why are we doing this rather than just declaring? The question was, the question really boils down to this. When you declare a variable student S versus resident students S versus non-resident students S, so these are the options for you, right? So now, in order to declare the type for S, you can either choose this type here, and this type over here. Each one of them has its pros and cons. So we'll get there, okay? Okay. Now, any other questions? Yeah.
What if we move line 7 before line 5?
You move line number 7 before line number 5.
Yeah, between 4 and 5.
Between 4 and 5?
Yes.
So that means you're trying to do the reassignments accordingly. You know, you can just do the trace yourself and see what happened. Basically, you can still do the reassignments. Okay? Okay. All right. So that's only about the intuition about these two concepts, polymorphism and dynamic binding. Let's now go to the little bit more systematic way of considering all the issues. Okay? Okay, that's exactly what I just illustrated. You can go over the slides. The slide also got detailed reasoning. Okay, you can go over them. Okay, polymorphism, dynamic binding. And now what I will do is I will now go to more about giving you the rules for reassignments or dynamic types. Okay, let's now talk about some terminology. I'll use an example along the way. Okay, so now this slide here is important. So now we talk about inheritance. Every time you got inheritance depends on what your application is. It can be the inheritance for students. It can be inheritance for other application. Okay, so now we talk about data type. Data type are simply just runtime values. When you talk about reference type, you're talking about different addresses for different kinds of classes, right? So that's something like a review. Now, this is what we need to put into context for this particular topic. When you talk about inheritance, you really have a type hierarchy. We'll see example in just a moment. Now, one thing we already know, in Java, the superclass of every class is called objects, which means every class inherits something from the object class by default. For example, the equals method that we talk about. Okay? That's a special case. And now, this is what I would like to start with. So now, let's first of all go over that. This is what I would like you to try as well when we just solve the problem. Every time when you see extents in your class, you should really try to draw an arrow accordingly. For example, let's say we have an example like this. We got so many classes over here. So now, if I have a class like this, make sure you put the arrow in the right direction. Okay, so now, in my Java class, I should say class B extends class A, right? That's why I got an arrow from B to A. So the direction should be like this. And also class C extends A, right? And also D extends B, E extends B, and also like this, right? I just put it down over here. Okay? I'll just put one example. For example, B extends A. Okay, that's why we got this arrow over here. Okay? And then so on. So if we give you just Java decoration, you can turn them into some graphical representation like that. Okay, so now, this one also is important. So when we talk about extend, so what we mean is, when we say it's transitive, let's see this. I want you to look at this particular class over here, class D. We know that D extends B, and B extends A. Right? So we got two arrows over here. So implicitly, you can think about D also extends A, even though we don't say that in the declaration. Okay, that's easy. If A is larger than B, B larger than C, we know A larger than C, right? That's easy. Okay, that's about transitivity. Okay, let's go on to the next one. And this is what you should know. Every class implicitly extends the object class in Java. Okay. Now, this is the two terms we should really clarify. One is about ancestor, one is about descendants. So far, we only talk about parents versus child. Ancestor is more like a generalized version for parents, and descendant is more like a generalized version for child. Let's see. It's very easy. What about ancestor? Given the class, how do we know its ancestor? You simply include the class itself. So a class itself is also its ancestor, just for our definition. And also, all the classes that A directly or indirectly extends. What do I mean? Let's say this. Let's just do some practice here. According to the diagram over here, what should be the ancestor for A? Basically, every class that A extends, and also including itself, as far as this hierarchy is concerned, what will be the ancestor for A? Just A. Let's not worry about objects. The object is always the ancestor, so we don't include that. In this case, ancestor would just be A, right? So what would be the ancestor for C? How many? 2. C and A. Agree? C and A. What's the ancestor for G? G, C, and A, right? Basically, you're going along this path over here. That's our definition. Yeah. So G, C, and A. That's the ancestor. Okay, so far so good? Get the idea? Basically, you want to find out, for G's ancestor, find out its parents, and all the way to the root of the hierarchy. Okay, that's about it. Let's see, that's about ancestor. What's so important about ancestor? Okay. So what we should do is, let's say over here, A inherits all the code from its ancestor classes. Let's see exactly what I meant by that. Okay. Now, according to this particular hierarchy over here, let's get something set up here. Let's say in class A, we got a method called AM. In class C, we got CM, and FN, GN, HN, etc. Okay, that's all we have. Okay, now, again, let's talk about expectation. Expectation is like what method can you call on this particular objects. Now, if I have a static type A, what can I call on that? Which method, according to the diagram? If I have A here, at least I can call AM over here, right? At least. What about if I have C over here? At least I can call the method that's defined at this level here. So that'd be CM. Anything else? AM, because that's inherited right here. And now, what about I have G? At least I got GM. I inherit from my parents, CM. I also inherit from my parents' parents, which is AM. So what does that mean? That means over here, you can see that G over here inherits all the code for the definition of CM from C, and also definition of AM from A. So that's why we can call GN, CN, and AM in the class G. Right? Okay? Now, that's about the ancestor. That also means the lower you are in the hierarchy here, the more expectation you have. Right? You can see that we start with A, which is higher in the hierarchy here. We only got one expectation, AM. However, when you go down this way over here to this G, but we actually suddenly we got not only just AN, but also we got GN and CN. So these are all the methods we can call. Right? We just get more expectation. All right? Now, that's exactly what I meant. So that means we got wider range of expected usages, okay, from the hierarchy. So let's define a symmetric notion. We just talked about ancestor classes. What about descendants? Descendant is simply the other direction. Descendant classes, again, also include the class itself, okay, just for our definition. And also all the classes that directly or indirectly inherit from this particular class. For example, over here, what would be the descending classes for G, for example? G over here. So all the classes that inherit or indirectly inherit from that, right? We definitely include J. Don't forget itself. Okay? J and G. What about the descendants for C? How many do we have? Okay, good. C itself, and also F, G, H, and J. So these are all the descendants. Now, what about A? Everything, right? Okay? I'll just say all classes over here. Simply because A is so-called the root of the tree. So its descendants is everything on the tree. Okay, just some terminology over here. And we'll actually use exactly ancestor and descendant notion to define the rules for doing assignments. That's somewhere we'll go into. But now, one more thing to emphasize, okay? When you talk about over here, let me just emphasize again. When we talk about class A and class G over here, okay? We know that G is a descendant of A, right? And what would be the expectation for G? We know that for any, let's say we got G, object G over here, right? We can simply call OG.GN. That's fine. We can also say OG.CM. That's also fine. We can also say OG.AN. That's also fine. So we got exactly 3 expectations for this particular type. Now, if you compare that with its ancestor, you seem to get much less expectation, right? Because you got, let's say, we'll just compare that side by side. Type A, object A. So what are the what's the expectation here? How many methods can we call? Just one. You can only say OA.AN. That's it. You can see this is just part of the expectation for the descendant class, but you get way more than that. Okay? I want you to keep this as an insight. All the rules are based on this expectation. Okay? Should we just do one more very quickly? That's just another example which we'll reuse over the lecture. So this one may be a little bit more less symbolic. This one here, we have a class called smartphone. Okay? Under the smartphone, we got iOS, we got Android. Okay? Under iOS, let's say iPhone 6s, iPhone 6s Plus. And under Android, we got Samsung, HTC, and under which we got different models over here. Okay, like that. So these are the classes. Okay. Now let's talk about methods. At the smartphone level, that's the minimum methods we can define. So we got dial and we got surf web. Okay. Now in this particular subclass over here, we still got surf web, but we can try to override the method. We can redefine how we can surf the web. For iOS, let's say we use Safari to surf the web. On the other hand, we can say in the Android, we surf the web using Firefox, for example. And then we can add new addition, expectation, like a method to it. You can say for iOS, we got a new method called FaceTime. And for Android, we got a new method called Skype, right? And let's say for iPhone 6s Plus, we also got 3D Touch, right? And for maybe this particular model for Samsung, we got Site Sync, whatever feature that it is. Okay, that's kind of the hierarchy we have. Okay, now let's do that something very quickly. What would be the ancestor for smartphone? How many classes? How many classes for smartphone ancestor? Just one. Smartphone. All right, thank you. What about Android? 2. Android and smartphone. Right. What about this particular one? Galaxy S6 Edge Plus. How many? 4, right? Along this particular path, we got 1, 2, 3, and 4. So itself, also we got Samsung, we got Android, we got smartphone. Okay, these are the 4. Okay, and then you can also try to figure out exactly what the descendants are for these 3. Okay, that'll be exercise for you, but you get an idea. Any question about defining ancestor and descendants? Okay, again, what you should really realize is when you go down by the inheritance hierarchy over here, you're defining more and more expectation because you're adding more and more methods and attributes. Okay, just more and more. Okay. Now, let's go back to the slides and then do a little bit more. So now, this is trying to link from what we learned last time. Inheritance is really about accumulating the code. Because every time you say extend a particular class, you're basically inheriting all the code from that particular class. You're really accumulating more. That's why me have more expectation than my ancestor. Okay? So now the lower the class is, the more code it accumulates. That means we got more expectation. That's something we just said. So now I want to go directly to, so what can you do in descendant class? You can define new attributes, you can define new methods, and also you can redefine or override existing methods. Right? So what does that mean? That means every time you can actually get wider range of expectation, right? Because when you go to descending classes, for example, if you get down to this level over here, this particular model of the smartphone has wider range of expectation for a smartphone, for sure. It got many more features than just a simple one, smartphone. Okay? And now here comes the important thing. Okay? We talk about something called substitution, okay? And we do have a rule for substitution. And the rationale, we have explained them already, but we'll do it again, okay? Let's read it over, and then we'll see how this can be seen from notes. When expecting an object of a particular class, let's say we are expecting a student class. We may substitute it with or reassign that into objects of any of its descendant classes. So what does that mean? Keep this in mind. Let's see on the notes. Okay, let's see, this is what we have. Okay. Again, we got this hierarchy here. We got students, we got resident students, we got non-resident students, right? This is what we have. I want you to look at the declaration over here. We got S, we got RS, we got NRS, right? They are of different types. We got students, we got resident students, we got non-resident students. By the way, you can see students, how many ancestor classes do we have for students? Just one, students. How many descendant classes do we have for students? Including itself. Don't forget, 3. Descendant classes for student will be students, resident student, non-resident students, okay? Now, let's talk about substitution. So what do I really mean by substitution? Let's say this. Basically, what I'm trying to say is, let me take one example for you. Can we just focus on this one specifically? Can I do S is assigned to RS? As we learned from before, we can, okay? Basically, what we are trying to say is, S, can we actually reassign S into a whatever object that's being pointed to by RS? That's what we are asking. Can we actually do that? Okay. Now, the rule is simple. Okay. Here's the rule. Let me just erase this. Here is the number one principle you want to keep in mind. Whenever I ask you about compilation, you only look at the static type. Okay, I'll write it down. When considering compilation, only look at static types. Okay, so now, when you want to judge to see if this particular line is going to compile or not, this line here, this is how we look at that. First of all, what is the static type for RS? Static type? Resident students, defined over here, okay? Static type, resident students. What's the static type for S? Students, okay? So far, so good. When we are doing substitution, we know that if we are going to substitute S over here by something else, we better substitute it by something that is going to have at least as many expectations as S. How do we get to something that's at least as many expectation? Do we go down the hierarchy or go up the hierarchy? We want to get more expectation. So let's say this. If we are expecting something for students, let's say, right? Now, can we substitute students by resident students? The answer is yes, we can, because for resident students, it's guaranteed to have all the methods or attributes over here that's inherited. You also got something that's additional, but at least what's defined over here for students is available. It's always there, okay? So that's why this is okay. So now when you look at this line over here, here's the rule. The static type of the right-hand side is a descending class of the static type of the left-hand side. That's the rule. How do you apply that rule over here? Let's try. The same rule is going to be applied for many times. Let's try. For this one here, the static type for right-hand side is RS, resident students. What about the static type for the left-hand side? It's students. Is resident students a descending class of students? Well, is resident student class a descending class of students? Yes, so that's why it compiles. This is exactly how Eclipse compiler tells. Okay? But it doesn't tell you so. That's why we got to learn. Okay? Now let's do one more. How do I judge to see if this line should compile or not? Should it compile? How do we judge? Look at the static type. What's the static type for NRS? Non-resident student, right? That's not NRS. And this is, the static type is students. Is non-resident students a descending class of students? Yes. So that will also compile. Okay, let's try more. Okay. What about this line over here? So when you try to do this substitution reassignments over here, what's the static type for S over here? Students. What's the static type here? Resident students. Is students, the right-hand side, a descending class of resident students? No, it's an ancestor, it's not a descendant. So this will not compile. Okay, that's kind of the rule of substitution over here. But the rationale behind is what I explained before. If you allow such substitutions to actually occur, you're going to crash your program. Okay, that's how we explained before. Okay, any questions until now? Okay, all right. So now let's talk about static type. Okay, well, we've already gone through the idea. Let's just review that very quickly. For the static type, any reference variable has a static type. Okay, it's what we declare that to be. Okay, if you declare Jim to be students, student is a static type. It never ever changes. It's always stay the same. Okay, and if I declare my phone to be of type smartphone, also it stays the same always. Now, let's have a look at this line over here. So what does that mean? We have already covered this. Whenever you have a static type, particular type called C, you want to know what kind of methods can you call on that particular objects. What I meant by is this. Again, it's more like a repetition of what we said before. Let's say this. Students S is something here. It doesn't really matter what the right-hand side is. The right-hand side is not relevant to our discussion. Okay? When I say S dot name, we know that it compiles simply because the static type for S is simply students. Does the student class define an attribute called name? It does. That's what we can see from over here. It's a name. On the other hand, if we try to say S dot premium rates, this is not going to compile simply because the static type for S is students. Does the student have an attribute called premium rates? No, it doesn't. Because for the student class over here, there's no premium rates. It's only existing in the subclass. So this one here, no. because the static type of S, which is students, doesn't declare premium rates. Okay? So static type is really important. It tells you exactly what you can call on a particular variable after you have seen that declaration. Okay? Now, one more thing to say. If I got another one, let's say called resident students, S2, and doesn't matter what this is. So now, because we know that resident students over here is a static type as well for S2, and we know that resident students is a descendant class of the student class, right? You can see resident students class is over here. It is a descendant class of students. That's what we can see from the hierarchy here, right? And now, because it's a descendant class, that means we got more expectation for that particular variable, right? That means not only that we got S2.name, also we can say S.premium rates. So that's also fine. So we got more methods to be called on that particular variable, okay? Okay, so now let's just go over that again. So we have a variable called gym of static type students. That means all the method defining student class, we can call that get tuition, register, and also we cannot call set premium rate, we cannot call set discount rate, right? Because it's not part of the class. Also, what about smartphone? According to the diagram over here, this is a smartphone, okay? If we declare my phone of smartphone, we can call only two methods. We can call either dial or surf web. These are the only two methods we can call, right? That's the only two methods we define in this level. And we cannot call FaceTime, for example, right? You can see that, according to that, if the static type is actually a smartphone, the FaceTime is only declared in the descending class level, which does not exist just yet. Okay, so we cannot do that. Okay. Okay, so now this part we have already said, so I'm going to leave you with that, just about the substitution as assignments. And this part here, I'm not going to go over everything, but we have already said that. We're going to do examples together. So basically, there are three scenarios for you. We're going to go over one by one. Whenever you talk about static type, it's really about what kind of substitution can you make. All you have to do is look at the static type and see the descendant class, ancestor class relationship. Okay, let's see example. I'll leave you with the, I don't need to just read them over. Okay. Okay, let's do one more thing and then we'll do examples. We just talked about static type, which never changes. But let's talk about something that can always change. That's called dynamic type. Okay? That's the more fun part. Because for the dynamic type, you have to keep track of them if you want to know the behavior at the runtime. Let's see that. So a reference variable's dynamic type is the type of object that it is currently pointing to at the runtime. For example, if you try to look at a few notes back over here, when we talk about S being pointing to either over here for resident students objects, at this point, the dynamic type is resident students. However, later on, after we reassign S to this particular objects, now the dynamic type is non-resident students. So it might change. But the static type never changes. It never. Okay? Let's see. Okay, now there are two ways for you to change the dynamic type. There are two ways. One easy way, the other one is a little bit harder. Okay? Let's go over them. One more thing to say. How do we visualize static type versus dynamic type at the runtime? I would say this is the rule. Whenever you want to draw boxes like this, remember every time, for example, when I have things like this, if I have an object like this, when I say new resident students, I'm basically creating an object of type resident students. That's why I simply draw a box over here and then put resident students over here. Okay, that's how we put the dynamic type. On the other hand, we typically don't really put the static type unless you want to clarify the context. Okay, that's kind of the rule, but you can, depending on what you need. Okay, I'll leave this to you. This one is not difficult. Now, how do we change the dynamic type? Two ways. The first way is very easy. You simply want to use the new keyword. Okay, now get back to your question. If you have, okay, let's see example over here. I will go to the substitution principle in just a moment. Let's say this. If you consider this line over here, we got students on the left-hand side, we got new and resident students on the right-hand side. So these are two different types. Okay? As we said before, Jim over here is the reference variable. Okay? And students over here is what we declare Jim to be. So that should be the static type. It never changes. Now on the right-hand side, we simply say initially, Jim is going to point to a resident student's objects. Okay, that's what we say. But the object arrow might change later if we decide to do so. Okay, well, we'll see how we can do that. One very easy way to see that is, let's see that. Let's see this. If I have students S is new, resident students. Okay, something over here. So now what does that mean? After this line over here, let's think about what's the static type for S and what's the dynamic type for S. Let's think about it. The static type never changes. It's always going to be what you declare S to be. So in this case, I'll put green. It's just going to be students. And what's the dynamic type? Well, at the moment, it's simply a resident student's object, something like this. That means S is now pointing to a resident student's objects. So the dynamic type is simply just RS. Let's try something else. Let's say for the same variable over here, if I say S is assigned to new non-resident students objects. Like that. You can see it's a different type. So what does that mean? That means we're going to say S rather than pointing to here, is now going to point to a new object over here of type non-resident students over here, right? Non-resident students. So now, what has changed? What has not changed? If you think about static type over here and dynamic type over here, after this line, what's the static type for S? If static type never changes, what's the static type right now? Student, right? Never changes. Now, what about dynamic type? NRS, because you simply redirect that into over here. So that would be non-resident students. So what do we observe? Static type never changes, always remain the same. As soon as you declare that, it's always fixed. However, one way to change your dynamic type is by simply reassigning your variable using a new expression over here, depending on what this class is. Okay, that's how you change dynamic. Approach number one. That's an easier way to see it. Okay. However, what would be the rule for you to say this? For example, what if I say something like this? I say students. Oh. What if I say resident students? Let's say S2. Can I say something like this? All right. It's something very similar to what we were trying to do for the reassignments. Okay, let's do it very quickly. What am I trying to do over here? I'm trying to say, given the static type for S2 being resident students, meaning that I expect the following. I expect to call something like S2 dot premium rates. I expect. However, if I allow this student to be the dynamic type, it's going to crash because student does not have premium rates. So that means this simply would not compile. And what's the rule for deciding? The rule would be whatever new dynamic type you put over here must be a descendant class of the static type you put over here. Okay, that's why you will see that rule on the slides. Okay, you will see that. Okay, that's about approach number one. Approach number two, how do you change the dynamic type? The answer is you can do reassignments of the variables. Okay, rather than seeing the explicit new keyword over there, you can just reassign the variable. Let's see. Okay. For example, let's see this. Let's just keep track of them without drawing a diagram. At this point, let's say after executing this line, what's the static type for Jim? Students. Good. What about dynamic type? Student, just the same. Okay? They can be the same. The only thing that's not allowed, the only thing that's allowed is as long as the dynamic type over here is a descending class of that. Okay? This one is also fine, right? Okay, very good. This one is also fine. At the moment, you can see Jim, RS, and NRS, they're all, the static type for Jim is students, RS, static type is resident student, and so on. Okay, let's try that. Is this okay? For this one, we already covered, right? Let's see. What are we trying to do here? If you try to do the reassignment here, the right-hand side, Jim, the static type is students. The left-hand side, the static type is resident students. Is students a descending class of resident students? No. So, does not compile. You're still learning, that's okay. You know, I can be a little bit tolerant, but you want to be faster, hopefully on Wednesday. Okay? How about this? No. Why? The complete answer, let's rehearse. How should you write this for left has 3? You want to say the right-hand side, the static type for the right-hand side is students, which is not a descending class of the static type of the left-hand side, which is non-resident students. That's what you should say, okay? When you talk about compilation, like here, the dynamic type doesn't matter. We'll get there, maybe next time, but let's keep something simple. What about this one here? Yes, right? Because the static type for RS is resident students, which is a descending class of the static type for Jim, which is students. Now, if this is okay, so what does that mean? That means we can execute it at a runtime. If we try to execute it at a runtime, at the moment, let's say before we try to execute this line, before we try that, what's the dynamic type for Jim before that? Student, over here, this line here, right? That's students. What about after this line? Okay, think about it. I'm going to draw some diagram here to show you how you can keep track. How can you figure out dynamic type? You have no way around but drawing diagrams. Okay, let's see that one here. Okay, think about it, and now I'm just going to draw something very quickly for you. Okay, and also give me one moment. I'm just drawing the diagram on the web, on the iPad very quickly. NRS, okay. Good, like that. Okay, if you have a look at that, let's review very quickly. At the moment, the dynamic type for Jim is students. The dynamic type for RS is resident students. Dynamic type for NRS is non-resident students, right? That's what we have. Now, let's try the following. If you try over here, let's say Jim is assigned to RS. Issue number 1, does this line compile? We look at the static type for RS. The static type for RS, if we go back, RS was declared as resident students over here, right? Resident students. What about Jim? The static type was declared over here, that's students, okay? I'm just trying to show you in case you want to watch the recording later. Now, whether this line compiles or not depends on whether resident students is a descending class of students. Yes, it does compile. What happens at the runtime? What happens at the runtime is Jim, rather than pointing to here, is going to point to wherever RS is pointing to. So now, after this line over here, what's going to be the static type of Jim, first of all? Why students? Doesn't change, right? It's going to be students over here. Now, what's going to be the dynamic type of Jim? Well, because it's pointing to RS, right? More precisely, when we try to do this particular reassignments, the dynamic type of Jim is going to be just the same as the dynamic type of RS. That's what's going to happen. Because we know that for RS, the dynamic type is RS over here. That means Jim also becomes this particular dynamic type. Okay? Will be RS. Hey guys, any questions about this? Okay. It's not too hard, right? Maybe you just need some time to review. Okay, one moment. I'll let you go earlier today, I promise. Okay, just a few things. Okay. Okay, you can just go for the rest. So now, what I would do is, I think this one maybe deserves a little bit more careful account for next time. Okay, so what I would do is I'll start from here next time. Okay, for your lab test 2, just make sure you arrive in time, and then I'll see you there. Okay.